I'd like to go over making a technical drawing in FreeCAD, one much like this one. Particularly, there's not much material out there that shows how to add symmetric tolerances or 6x symbols that would be a part of your dimensions. So let's go over that in this video. To start off with, I've created this part in FreeCAD as something to draw. You can download this from my GrabCAD account. The link is in the description, and follow along with the video as you watch. But this would need to be drawn. So we go to TechDraw, and we have two options. We can insert default page or a template. I prefer doing a template, and I like the A4. Even though I'm an American and maybe should like the US letter landscape, I think A4 landscape is a wonderful format. So I can open that up, and I have quite a nice, pre-made title block. And the first thing I'd want to do is insert a view of my part. Now I can navigate back to my part using the bottom tabs, and notice this is on a very random view. The view that I'm looking at my model with is the view that is going to be inserted into the drawing. So to get the right view, I'm going to look straight down from the top, which is much more handy when drafting. So going back to my page, I can highlight either the last feature or the body of the part that I want to insert, and choose this button, Insert View and Page. This comes in at a 1:1 scale. If you don't like the scale, you can always change the scale to something like 0.5 and hit the Recompute button, and it goes to whatever scale you wish. I think 1:1 is okay, maybe a little bit large, but okay for what I'm looking for. So I'm going to stick this in the corner, and I want to do a section view on this. So to insert a section, I'll use this button, Insert Section View and Page, and I can choose whatever section view that I want to. If you want to move this section up or over, you can always adjust the origin X and origin Y. Origin Z is usually fine the way that it is. I'm going to say OK because I do want the section how it came in. And I can move this to the top. Now I may want to focus on very fine details on this, and so I want to add a detail view in this section AA. So with this highlighted, I can choose Detail View here. And notice it gives me a nice little detail circle and a detail over here. With my detail view highlighted, I can make some adjustments because this is not a very helpful detail view. I'm going to start by adjusting my anchor position, and anchor is of course this circle here that FreeCAD references. So I expand my anchor view, and I can move my X. Let's try 35 and recompute, and that gives me a little bit more of a reasonable position. I'm going to change that probably to, let's say 31, and we'll recompute that position. Now I want to adjust my radius of my detail view to be a little bit larger. Make my radius something like 20 and recompute, and a little bigger, 25. And that looks like a pretty reasonable detail view. Notice this is coming in at the same size, so I can tuck this a little bit further up. And I can adjust the scales with my detail view highlighted. We can make the scale something like 1.5 and recompute. And there we've got kind of a better looking detail view. So I'll leave that there, and we can begin dimensioning. There's a few things to notice. We have a few intersecting views here. The first thing I can do is maybe optimize my detail view a little bit more with the radius so that there's less intersections, say 23, and recompute. Make that even smaller, 21. And that looks about right for a good detail view. Notice I'm close to the edge, but just fine. So that can help with the landscape, or real estate I should say. If you have a problem, I can scoot this down a little further. But you don't have to worry about the labels here or the borders, because how the drawing is actually going to come out, you can view that with this button. Turn view frames on or off. That's how the drawing is actually going to look. So we'll probably need to add in another section AA coming up. Okay, so for adding dimensions, let's go to perhaps these 2 points. If I want to put a diameter on this bore, I can add in a horizontal dimension. And if you'll notice, I'm in millimeters, right? And you can always tell edit preferences, units, standard millimeters, apply, okay. That's very important. If you're in inches, what I'm about to do isn't going to work. But let's say I want to add a diameter symbol up before this dimension, because this is coming in as a linear format. I want a diameter. And you may say, well, hey, I can just change this from distance in the x direction, I can even do just straight distance, to diameter. But if I do that and rebuild, then this all of a sudden is completely wrong. This is not a diameter of 0 that I'm trying to measure. So diameter in this format doesn't work. We're going to go back to distance and rebuild. What I want to do instead is come down here, and I can use something in Linux known as Unicode. What I'll do is make sure that your caps lock is off, Control Shift U. Notice the U with an underline appears right there. And then I'll say something like 2300. And that Unicode makes a diameter. So if I hit enter, that U with the underline 2300 turns into a diameter symbol. And if I update, then I get a diameter symbol in front of my dimension. And that will be very handy if you're trying to conform to existing drafting standards. So I have a diameter of 29.46 millimeters in this inner bore. If you want further clarity, you can also, after the format code here, maybe do a space and say, in capital letters, ID. We'll rebuild that. So now we've specified that we're measuring the ID and not the OD of the chamfer. Next thing that we can do is do another diameter here. And remember, this section AA is not going to show up in the final drawing, so I don't have to worry about something being on top of something else. But we can use the same thing. Again, Control Shift U, except that didn't work because I think my caps lock is on. So Control Z to get that back. Control Shift U, 2300, enter for a diameter symbol, and ID at the end. We rebuild, and there's our diameter symbol with the ID. Oh. Highlight these two again with the control. We'll go Control Shift U, 2300. I bet you're getting really good at this by now. And we're going to say ID. And there's our dimension. I might want to dimension the OD of this tongue as well. Drag that to a place that makes sense. Control Shift U, 2300, enter. And we'll say again OD this time. And there we go. Now, ASME Y14.5 2009 standard says that you can stagger your dimensions, and at least you should, to increase readability. And I think that's some pretty good advice. I may be running out of real estate, so perhaps I can scoot this detail view down here. And yeah, that would actually work pretty well. Next thing that we want to do, add some more horizontal dimensions. So we'll go there. And we can even add a clarifying text, inner groove, if we wish. Of course, that seems to take up the whole thing, so I think that'll be just fine. Next thing we'll do, are you tired of horizontal dimensions yet? I think we're almost through. Better select here and here. 88.9. Control Shift U, 2300. And then we'll go with something like outer groove. And we have a nice dimension drawing of that. Next thing, again, almost done with horizontals. You can use Control and highlight these 2 points. Two, 3, 0, 0. And that's probably pretty obvious dimensions, so we'll leave that just with a standard diameter. I can add my part OD, and you can also use diameters looking straight down on a part. In this case, you can use the diameter button with what you want to dimension highlighted. And your diameter comes in quite nicely, as you would expect. That's a pretty brilliant function to get that to be able to update like that. So our OD is 1.6, and of course we can say part OD. And notice the diameter symbol is already inherent in that dimension that we just put. If we want to save some real estate, we can probably move this diameter to this ID as well. We'll see how it goes. Next thing, we can add a few vertical dimensions. And you'd probably want to do this like with a datum dimension or something like that. And it all depends on design intent on how to dimension. So if I say something like our overall part height with a vertical dimension, we can dimension that, and then I would say select from this face down to this little step that we have, vertical dimension. You might want to locate this groove. Now it would be very hard to measure from here to here. So if you want to accept tolerance stack, but you certainly can add a dimension from here to here, and then dimension the groove depth off of that face. That would make it much easier to dimension in practice. But it's important to keep in mind what stacks you're willing to accept and everything at the worst case. So I can choose that, or it might be more readable to come down here, whatever you prefer. But I had too many things highlighted. So we can choose, dimension like that. I am going to intend on fully constraining this part. There we go. Select this vertical dimension. That gives me a height of my step. Now I'm probably going to need an angle dimension here, and that can be easily accomplished choosing this line and say this line and angle. That's probably the easiest notation to be able to read that. I guess 335 is a correct angle there. I'm not seeing the angle symbol, so we can go ahead and add one. So again, that's Unicode, and I go to the end of my format, Control Shift U, again with caps lock off. 00B0 would make a degree symbol with the correct code. Rebuild, and there's my degree symbol, so 335 degrees. I might want to go down to my detail view now and start choosing something like a radius value. So if I choose that radius behind those points, you can hardly see it with the points turned on. And there's my radius symbol there. Notice I can insert a little radius, however I think is best. Now, I have the same radius here and here. And since I'm looking at a section view of the part, then I can very easily put in 3x in front of my radius symbol. And there we've got our standard radius. So that's a nice way to not have to dimension everything, and that is perfectly allowable. And ASME Y 14.5 2009, check your drafting standard if you're using something different. Now, chamfers. For chamfers, I prefer using probably a horizontal, maybe a vertical dimension. And then at the very end I can say by 45, and then again Unicode Control-Shift, turn off my caps lock, Control-Shift-U, 00B0, 4 degrees, and recompute. And then I could probably say, in the beginning, I have 1, 2, 3 standard chamfers. So 3x, I'll do a capital X there, recompute. 3x, 1.27 by 45 degree, and that would probably be a perfectly fine notation for a chamfer. So I've got my radius and chamfers worked out. Am I missing any dimensions up here? And it makes it much easier to see if I turn my view off. I could probably make my drawing much more clean by adding my angle down here. I can select these two lines and add a simple angle. 25. And again, Control-Shift-U, 00B0 for the degree symbol. 25 degrees. I may want to add some specific tolerances, like how far we come out over here. Of course, it's with these arc centers. I guess I'll reference off the arc centers because it's more reliable to do it that way anyway. So I'll give the distance between these arc centers, and on this dimension I may want to add something special like a bilateral dimension. So to do that, you can say over tolerance. Let's say I can allow this to be 0.75 millimeters over, and under I can add 0.25 millimeters. And notice this updates quite nicely, so I can create a bilateral tolerance plus or minus. And speaking of tolerances, I may want to add a symmetric tolerance, and so I can use this pre-existing part OD that I've made. From here I can again use Unicode, and I would say Control-Shift-U for the bilateral symbol, 00B1, enter, and that gives us our plus or minus. I can type in whatever tolerance I want, for instance 1.25 millimeters, and if I rebuild, it is added here. So that's how you would handle symmetric tolerances and bilateral tolerances. I want to turn my attention to the title block. If I recompute and add back in our frames, notice we've got some green guys when our frames are on that aren't there when our frames are off. This, of course, is to add in a custom text value. So I can say small, in fact I'll do it in all caps, small ring, and subtitle. I could probably say interpret per ASME Y 14.5 2009. So I've got a little drafting standard. I can say designed by Joseph. That looks like the date today, 2nd November 2019. Our predominant scale, we'll call that 0.75, and we can specify the scales of our views. Weight, I have no idea. I'll say 0.5 kg. Maybe it's made out of depleted uranium. Drawing number C17-0035. Sheet, I can say 1 of 1. That's looking pretty good. So revision, and I haven't covered annotations. We can put in an annotation. Insert annotation here, and notice annotation is not visible when you have the final drawing, so ignore this. With this highlighted, I can go to my default text. I like clicking these, and I can say the letter A. You can probably not see that very well on my screen recording, but under A we can go with something smaller like 3 millimeters, or in fact I can insert some initials instead. We'll go with something like JBL. I can move my annotation here. And if I move my detail view over here, perhaps I can insert some drawing notes, and this is how you do a multi-line annotation. We do something like notes, next line, 1. How about burrs must be removed, note 2. Material to pass inspection, hit enter unnecessarily. And then of course I must reformat, let's say 2 millimeters. Except I'm missing my N. For all you perfectionists out there, I will re-add my N. There we go. So that's how you would do a multi-line annotation. So if I get these things to cooperate with me a little bit more by changing this real estate around, I can lower these a little bit. I can maybe add in a small isometric view. That would be easy to do if I go to my ring, isometric, insert view, but I have to again highlight my body. And there's a little isometric that I can scale down. Adding in my last annotations. Section A-A. So that will show up. And then annotation again. Detail. Whoop. Let's try that again. Detail 1. You could also add a scale on a second line if you wish. It's probably in a drafting standard, but I'm not a master of drafting standards. And there we have a drawing. Now that I'm looking at it, it might be more organized to move notes down here. And I can even add another annotation right here. And under default text, what am I, oh darn, I was going to say what am I typing, but then you just saw it. So with this view, make that something like 2 millimeters. Oh, we could probably get away with 4. Nope, certainly not. 3, 2.5. That's probably your best fit. And there we have it. So when we're feeling ready to export to, I prefer PDF. You can also do a SVG, and you might even be able to do, yep, there's your DXF. You simply say export PDF and specify your file path to save. And after you save, and if you have any discrepancy, you can always hit this button twice to get everything the same again. And after you save, you have a beautiful PDF drawing. I hope this video was helpful, and if it was, please subscribe, and I'll see you in the next one.